Okay, let's start from where we stopped. If you remember, we were trying to find that point where the cost is least, and if you also remember, we were talking about a bowl-shaped curve where we were trying to find the W and the B independently such that the cost is minimized. So in this case, let's focus on W because the calculation of B is going to be exactly the same. So let's focus on W for now. So we are interested in this point where the cost is lowest and this axis is W, and we are interested in finding this W. So when the machine initially randomly assigns W, it can lie anywhere on that line, and for us to be able to come up with this point, we have to use the trick of tangents. So let's draw tangents at various points of this curve. So for instance, the tangent at this point is this, the tangent at this point is that, and the tangent at that point is this. And the corresponding values of W are this for this tangent, this for that tangent, and this for this tangent. So when the machine randomly comes up with a W initially, it can be anywhere, and let's assume that it is this for now. So if this was the randomly assigned W, then the value of the tangent is going to be positive, and we basically want to reduce a number from this W so that it actually comes closer to this W. So our task is to reduce this W. Similarly, if the machine had randomly assigned a W which is here, then our task would have been to increase the value of W such that it comes to this point. And here the slope of the tangent is negative. Also note that we can simply subtract the slope of the tangent, which is positive in this case, from this W, so that we are subtracting a positive number from this W, and it actually goes behind in this case. And similarly, in this case, if we subtract the slope of the tangent from this W, it is going to go ahead because we are subtracting a negative number from W, so it's going to go ahead. But if you also look carefully, the slope of this tangent is quite high because it's quite steep, this line. So if we just subtract that value from W, it is going to overshoot our expected W and go much further behind. So to avoid that, we are going to multiply the slope of the tangent with a very small number and then subtract it from W. Similarly, to avoid the same problem of this W's new value overshooting the expected W, we're going to be multiplying the very small number to the tangent of this at this point, and then we're going to subtract it from this W, so that we are basically adding a positive number to this W, because the negative slope multiplied by a small positive number and then subtracting that from W is going to be adding a number to W. It's going to increase in this direction. So if we do this a lot of times, we are going to slowly, gradually converge to this W, because at every point on this side of the curve, the slope of the tangent is positive, and at every point on this side of the curve, the slope of the tangent is negative. So you can imagine that if we subtract the slope of the tangent when multiplied by a small number from the W, regardless of where it is on this line, we're going to eventually converge to this point if we keep subtracting that multiple times. Now, just as a refresher, the slope of the tangent at any point is the vertical distance on this triangle divided by the horizontal distance on that triangle. And here we are calling the vertical axis as J and the horizontal axis as W. Basically, J represents the cost. In that case, the small height of this triangle is going to be dj. Now, why this d is something we'll answer later, but for now, assume that this small height is dj and this small width is dw. So the slope of this tangent is going to be dj by dw. So if we have to reduce the value of w from this point to somewhere here where the cost is minimum, we are going to be subtracting this dj by dw multiplied by a small number from this w. So in other words, from this w we are going to be subtracting dj by dw multiplied by a small number. When this happens, the value of w is going to reduce, and hopefully after doing it n number of times we will converge to our expected w. Well, this is in a nutshell how the machine is able to come to the correct value of w regardless of where it starts, and this is the crux of the entire process called gradient descent, which is at the core of most of the machine learning algorithms. So this is the end of this video. This was linear regression. In a future video we'll be covering logistic regression.